The set are NH3, PH3, ASH3, SBH3. This is the question. Arrange the following in the decreasing order of stability. Answers to such questions are very simple. I can just give you the answer straight away. But the question is whether you will be able to remember that for a long time or not. That is why the explanation following the answer is more important than the answer itself. My aim is not just to give answers to these questions. My aim is to make you answer any such similar question. There can be hundreds of questions from different chapters. Look here, NH3 more stable than PH3 more stable than. The answer is over. What is it you learn? The question is answered. You will find this list in everywhere. But you should know what is stability and why is ammonia the most stable. Listen to me. If I say HI is less stable, if I say HI is less stable, what do I mean by that? That HI and heating will give hydrogen and iodine atoms easily. What is the meaning of HI is less stable? When I say HI is less stable, what do I mean by that? Hydrogen and iodine atoms are easily formed. So similarly, when I say ammonia is very stable, what does it mean? Ammonia and heating doesn't give nitrogen and hydrogen atoms easily. The bond between nitrogen and hydrogen is not broken very easily. So this is the meaning of HI is less stable. If I say HF is highly stable, HF is highly stable, HF, H2O, HF is highly stable. What do I mean by that? HF, even if you heat to a very high temperature as high as 1000 degrees also, even up to HF you don't get hydrogen and fluorine atoms easily. So HF is highly stable means the bond between H and F is not broken easily. This bond is not broken easily. The covalent bond between hydrogen and fluorine is very, very strong. So how to remember this? Small atoms form stronger bonds. Small atoms form stronger bonds. So NH bond, nitrogen being a very small atom, this is NH bond, PH bond, ASH bond. So smaller the size, greater the overlapping. Therefore, this is a very strong bond. Small atoms form stronger bonds. This is true except for halogens. Halogens. I said halogens, not compounds of halogens. I was only talking about F2Cl2Br2I2. So small atoms form stronger bonds and therefore they are more stable. Ammonia is more stable than PH3, more stable than like this. Alright. So you use the same logic for this one also. H2O, H2S, H2Se, H2T. So when all these four are heated, H2O will never decompose to give hydrogen and oxygen atoms. So thermal stability or the so-called stability. Stability of H2O greater than H2S greater like this. We have already discussed NH3 greater than PH3 greater than ASH3 etc. So we are discussing the thermal stability of hydrates of 5A, 6A. What about 7A? HF, HCl, HBr, HI. Which is most stable? Small atoms form stronger bonds. Once again. Between methane, silane, germane, stannane. Hydrates of, so hydrates of fourth group, carbon, silicon, germanium, stannum. Hydride, a compound formed with carbon and hydrogen. Hydride is a compound formed between carbon and hydrogen. So methane, silane, germane, stannane, small atoms form stronger bonds. So the trend steadily. So these are the hydrates of fourth group. These are the hydrates of fifth group. These are the hydrates of sixth group. These are the hydrates of seventh group. So our heading 5A, 6A, 7A together is justified like that. Because we are not, strictly speaking, we should be talking about this only, hydrates of 5A, because we still are in 5A. We were discussing elements of 5A. But along with the 5A, we are discussing 6A and 7A also. Small atoms form stronger bonds. Next, we conclude 5A with one of the most important questions. Discuss the manufacture of ammonia in Haber's process. Very, very, very important, Haber's process. Explain the manufacture, discuss the manufacture, or what are the conditions favorable for the manufacture of ammonia. Look here. Nitrogen in gaseous state combines with 3 hydrogen in gaseous state to give ammonia. So, when nitrogen and hydrogen are combined, ammonia is initially formed. But the trouble is, whatever ammonia that is formed will once again decompose. So, both the forward and backward reactions continue to take place, and there will be a point where the rate of the forward reaction and the rate of the backward reaction are equal, which is called a state of equilibrium. All of us know this. State of equilibrium. So, nitrogen initially combines with hydrogen forming ammonia. So, initially the forward reaction will be taking place and backward reaction also will be taking place. So, at some point an equilibrium is attained. Means neither the composition of concentration of nitrogen and hydrogen is increased, nor the concentration of ammonia is increased. If one molecule of ammonia is formed, one molecule of ammonia is once again decomposed. So, you will not be getting more and more ammonia. So, the quantity of ammonia formed will remain the same at equilibrium. So, now we have to turn this situation where we get more ammonia. What are the conditions favorable? So, first condition favorable is whenever there is an equilibrium, if you increase the concentration of reactants, the forward reaction will take place. Of course, they are at equilibrium, but when you increase the concentration of nitrogen and hydrogen, so what is it? Increase the concentration of reactants. All these things after equilibrium is attained, mind you. After the equilibrium is attained, This is very important. All these things we are going to discuss now only after the equilibrium is attained. Increase the concentration of reactants, that is nitrogen and hydrogen. So, you add more nitrogen and hydrogen once the equilibrium is attained, you will get more and more ammonia. 2. Decrease the concentration of products. Decrease the concentration of products from the equilibrium. That is, remove ammonia. How will you do this? You send the entire reaction mixture to water, ammonia is dissolved, nitrogen and hydrogen are not dissolved, you bring them back once again to the equilibrium. So, adding reactants, removing products. So, if you add more and more reactants, more ammonia is formed. If you remove whatever ammonia is formed, you take that home with you, and more ammonia is formed. So, concentration of reactants increases, forward reaction will take place. According to Le Chatelier principle, if you increase the concentration of reactants, forward reaction. If you decrease the concentration of products also, forward reaction. Here, what is it we are interested in? We are interested in getting more and more ammonia only. We want more and more ammonia. Therefore, you add the reactants, you remove the products. And thirdly, as you can see, you have 1 mole nitrogen and 3 mole hydrogen here. Total 4 moles, 4 volumes is now becoming 2 volumes. Whenever the number of moles decreases, 4 volumes or 4 moles, both are one and the same. 4 volumes here become 2 volumes. So whenever the volume is decreasing, you have to create